So tomorrow's test has 16 questions on it. On the test, no proofs. The majority, I think, of all the questions, they're all calculations. So most of them, you're finding the value of x, except for the 10-7 questions where you need to find the equations of the circle. So no proofs, no calculator use. So you have to do all the calculation by hand, so no calculators. Also, you could get fractions, depending on your version, or decimals, or even radicals, which are square roots. Now, there will be one word problem, and that word problem is going to ask you to round, obviously you're going to have decimals, round your answer to the tenths place. The rest of the questions besides this word problem are just going to be, they'll give you, either I'll give you pictures of circles, and then you're either going to find a missing segment, or you're going to find X, or you're going to find a missing angle measure. It could be in the circle, it could be outside of the circle, you could be using arc measures, anything that we've learned. So 16 questions, no proofs, all calculations except for the 10-7 questions where you're writing the equations, and then also graphing the circle. Any questions before we start going through the review? All right, so remember, don't just focus on the review that I gave you for homework that was due this morning. Again, warm-ups are always an excellent way to review for a test or a quiz. So go back through and redo maybe that 10-5, 10-6, 10-7 warm-up that we already covered. Also, homework and notes are also good resources to use. I also have that extra review that is posted on Canvas. It's no submission, and the answers are included with it. So if you're looking for additional practice problems, you can do that. But what I'm going to do now is I'm going to go through the practice Bs that you did for homework. I'm going to talk about what was covered in each one of the sections, and what you should be focusing on and what you should be memorizing. So let's take a look section by section. Now 10-5, this was mostly focused with finding angle measures or finding arc measures. And here we learned about the floating angles, where you took the two intercepted arcs and you added them and then divided by 2. We also had the scenarios where we were looking for an outside angle, and we did the big arc minus little arc. And then we also had the circumscribed angles. So lots of different formulas. That big arc minus little arc was big, and that's what we would be using here to solve 8, 9, and 10. Now, let's just go through, and again, I'm not going to give you something like 1 through 6, where I give you one picture and I ask you 6 questions about that one picture. I don't like to do that because what I find is, soon as you get one of them wrong, then that can snowball, and then it makes the rest of the questions wrong as well. So I always try to focus on one picture and ask you one question from that, so you don't end up getting a whole bunch wrong just because you got the first one wrong. But let's just go through this and let's practice finding the answers to these questions. Now, there's not a right or a wrong, well, there is a wrong way, but there's multiple different correct ways to find the answers for 1 through 6 here. What I recommend you do is don't necessarily answer them in order. Look at the picture, look to see what stands out to you that you see as like maybe an obvious clue of where you could start. Because sometimes you may have to fill in maybe arc measures or angle measures that you may not need to answer 1 through 6, but they will help you to solve them once you do figure it out. So for example, the first thing I noticed right away is that CF here, this is a diameter. And I noticed that from my prior knowledge from the beginning of chapter 10, that when I have a diameter, it's going to split my circle into two semicircle arcs. So the gray one that I just highlighted, this is a semicircle arc. And since I already know part of it is 120, then the rest of it is just going to be 180 minus 120. And this little piece down here is going to be 60 degrees. Now notice they didn't ask me to find that arc measure in any of the questions. But what I can do is once I fill in that piece, it's going to help me to find the other angles. Now notice the other side has a congruency mark here. So this little piece is also 60. And then notice that this is also a semicircle arc. So then I could also realize that this piece of the circle is also 120 degrees from here to here. Then from there, I can start using all of this information that I filled in, even though it wasn't asking me to find it. So for example, if I want to find this angle up here, notice this angle is going to use this newly found intercepted arc of 60 degrees. And when it's an inscribed angle, which was really from the beginning of the chapter, the inscribed angle is always half of it. So this angle up here is 30 degrees. I could do the same thing on this side. Just by finding these two angles, I've just answered a couple of my questions. So for example, it wanted me to find, for example, AFB. Let's see, is that going to help me now? Well, yeah, it does. So let's see. I have D, like number 5. That's this angle right here. DCF is this 30 that I just found. Then if I wanted to find the other one with the C in the middle, let's see, BCD, let's see, this angle up here, BCD, I could just add the two 30s, and I got 60. And then from there, let's see what else we can find. Now, in addition to dealing with circles, we also have some triangles going on here. So if I just realize that this one right here is a right triangle, and I can see that this angle right here is a right angle, and I knew this top one was 30, then this bottom corner one right here is going to be 60. And that's going to be the answer to number 3, CEF, and it's 60 degrees. I could do the same thing for the first question. The CAF, again, I've got the right triangle here. So CAF, number 1, is also 60 degrees. Now, if I want to find AFB, notice this little triangle here. And notice since this side is a right angle, so is this side. And if this angle is 60, then this angle, AFB, is 30. So just by finding those arcs that I really didn't need at the beginning, it's now helping me to find all the answers to all of these angles that are asking me to fill in. And then CFB, that's going to be this angle right here. And notice I got another right triangle here, right here. So if this one was 30 and this one's 90, then AFB is 60, or CFB, sorry. So again, sometimes to answer the questions, you may have to find other pieces first. So again, and we used prior knowledge, stuff from the beginning of the chapter. Now, for the next question, this is where we're using our floating angle skills. Now, it says here in number 7, which one is not true? So let me go through and check. A, B, C, and D until I find the one that doesn't work. Now, for angle 1, this is where we're learning not only about our floating angles, but when we have a tangent and a chord, when they intersect, the angle that is formed by that tangent and chord is going to be half of its intercepted arc. So angle 1's intercepted arc is going to be 95 plus 125 divided by 2. So let's see if that gives me 110. So when I add 95 and 125, I end up getting 220, and then 220 divided by 2 is 110. So answer choice A is correct. Let's go ahead and look to figure out how we can find the measure of angle 2. Now, one quick way to find angle 2 is realize that this is a straight angle, this tangent, and 1 plus 2 is 180. So the fastest way to find 2 would be to take the angle I just found, angle 1, and then subtract it from 180, and angle 2 should be 70 degrees, which it is. Now, I could have also done the same thing that I just did for angle 1, and angle 2 is going to be half of its intercepted arc. So I could have also added 75 and 65 and divided it by 2. Once I add these two, I get 140 and divide by 2, and I get 70 that way as well. So different ways to go about doing these. Now, as far as angle 3 and 4 go, this is where I'm using my floating angle skills. So remember, when you have an angle that is formed by two chords that intersect, and they're not intersecting at the center, then what we're going to do is take the intercepted arc of the angle, which is 95, and the intercepted arc of its vertical angle, add them, and divide by 2. Once I add 95 and 65, I get 160 divided by 2, and that gives me 80 degrees for angle 3. Now, that one is good. And now the last one, obviously, answer choice D is wrong. So notice 3 and 4, again, straight line, straight angle here. Fastest way to find 4 would just be to do 180 minus 80, and angle 4 should be 100. Notice they told me it was 90, so that's the one that's wrong. Now, we could have also done our floating angle theorem here, and we could have added 125 and 75, and then divided it by 2. Divide by 2, and I get 100. So again, that would have been another way that we could have done angle 4 if we would have found that one first. So again, understand how to use that floating angle formula where you add the arcs and divide by 2. Then the next one, this is where we're going to be using our big arc minus little arc divide by 2. Now, technically we can use it for 8, 9, and 10. So remember, it's the outside angle is equal to the big arc minus the little arc. Divide by 2. Now, I can do that on number 8, but what would have been the better formula to use for this one? Angle X is a circumscribed angle. So the faster way to do this one would just be to take 180 and subtract out the central angle. And angle X would be 50 degrees. That's the faster way to do number 8. Number 9 and 10, I need to do the big arc minus little arc. Now, when you guys were doing this in class on Thursday, number 9 was a big question that a lot of people were getting wrong because they forgot to distribute the subtraction sign. So for number 9, I'm going to label my picture. So this is my big arc right here. This is my little arc. And then my outside angle is this 39. So what I'm going to be doing here, let me do number 9 down here. I'm going to be doing outside angle is equal to big arc 17x minus 6 or plus 6 minus 7x minus 2. Now, notice how I put them in parentheses, because what we're doing is subtracting the entire blue quantity. So I need to distribute this subtraction sign to both. So what this is really going to turn into is 39 equals 17x plus 6 minus 7x, and then the negative when I distribute it here turns into a positive 2. And then it's still divide by 2. I'm going to combine my like terms. So 17x minus 7x is 10x, but then 6x or 6 plus 2 is 8. Now, at this point, you can either multiply both sides by 2 to get rid of the fraction, or what I saw a lot of people doing on Thursday is they just wanted to divide both of these by 2 and then leave it as 5x plus 4. And then they weren't dealing with such large numbers. You can do that. Or if you would have preferred to solve it this way, you would have times both sides by 2 and then made it 78 equals 10x plus 8. Either way, so if I do it this way, subtract the 4, divide by 5, 7 equals x. And even if I did it this way, this is either or. You don't have to do both. And then 10 divided by 70, you get 7 this way as well. So it doesn't matter which way you do it. Now, number 10, it's the same thing. It's big arc minus little arc, but we don't have an expression to subtract. So that one's a little bit easier. So for that one, again, big arc is the 118. Little arc is the x, and then the outside angle is the 24. So for number 10, what we're going to be doing here is 24 is equal to big arc, which is 118, minus little arc, which was x, and then divide by 2. Notice on the other one how I could divide both the numerator there by 2. This one I'm going to get a fraction. So instead, I'm just going to multiply both sides by 2 to clear it, instead of trying to deal with a fraction there. So then I get 48, 2 times 24. Move the 118. Negative 70 equals negative x. Divide by negative 1. And x equals 70. And that would have been little arc. Now, you won't have anything as challenging as number 11. Number 11 was another big one that confused a lot of people. Now, remember, whenever you have a circle and you have two tangents that are forming the outside angle, we're going to do big arc minus little arc. But this is the scenario where we can get away with being only given one piece of information. So this would be my little arc, which is what they're asking me to find in 11a. So I'm going to call this x. Then my big arc here, I'm going to call this 360 minus x. So I'm still doing, so this is big, this is little, and then this is the outside. So I'm going to do 60 is equal to big arc minus little arc divide by 2. So I end up getting 60 is equal to 360 minus 2x divide by 2. Now you can either multiply both sides by 2, or if you'd rather simplify this first, make this a 180, make that a 1, Then you're dealing with a little bit smaller numbers. Subtract. Negative 120 equals negative x. Divide by negative 1. I can't have a negative variable. So EF is 120. I can now repeat and use this exact same formula to find FG and GE. So now, if I want to focus on this angle, the 80, now what's happening is my big arc is over here. Let me do maybe green. So now big arc would be here, and that would be the 360 minus x. And then the one that they're asking me to find, this little arc, would be x. So I'm doing exactly the same thing. I'm going to do 80 equals 360 minus x, and then minus little arc, divide by 2. So the same thing. Divide by 2, and then it turns into 80 equals 180 minus x. Subtract. I get negative 100 equals negative x. Divide by negative 1, and x equals 100. So now the answer to part B is 100. Now, the faster way probably to find GE instead of doing that again and using the 40 would be to take the 2 you already have, add them, and then subtract that from 360. And then that would give you 140 for the last remaining piece of that arc. So that was all of the stuff you need to know from 10.5. So again, floating angles, circumscribed angles, and then the big arc minus little arc to give you the outside angle measure. 10.6 is where we focused on segments. So here we had 3 main formulas that we needed to cover. We needed to either cover for numbers 1, 6, and 8. This one used where we took each of the segments. So like this little piece times this piece. So I would do x plus 5 times 28 is equal to 2x times 21. So what I'm going to do is distribute, and I get 28x plus 140 equals 42x. So here in this type of problem, the segments products are what's congruent, not the chord length. So then here what I'm going to do is move my x's together, and I get 140 equals 14x, divide by 14, and x equals 10. This is the type of formula you're going to use for questions 1, 6, and 8. Now, if you do the next one, number 2, notice this 20, this is a tangent. Then this one right here, this is a secant segment. So remember, for the secant segment, it's whole, so x plus 42, times this external piece. So for this one, it's tangent squared is equal to whole secant times the external piece. And this would have been used for question number 2, number 4, number 9. Now, the common mistake I saw was with number 9. So let me go ahead and work that one out. And then if you want to see 2 or 9, I can do those as well. So let me do number 4. So again, the 3, this is my tangent, the 3x. This over here is my secant segment. So the whole thing is 2x plus 10. And then the 2x is the external. So I'm going to be doing 3x squared, that's the tangent, is equal to whole times the external piece. Now, the common mistake I saw with the red was people squared the x, but they forgot to square the 3 as well. So that became a 9x squared. Then for the pink, we have to distribute. Okay, so then I need to square and then multiply. And now I need to get my like terms together. So what I would do is subtract 4x squared. And I get 5x squared equals 20x. Now at this point, it's not going to be a trinomial, but I can still factor it. I could factor out a GCF here. So 5x squared minus 20x equals 0. We're going to factor out a greatest common factor of 5x. And then we're left with this. I set each factor equal to 0, as well as this one. And now I solve each. So you will be factoring tomorrow, whether it's a trinomial or a binomial. This gives you x equals 0. This gives me x equals 4. Remember, when you get to answers, you need to check it. If it makes any of your segments a 0 or negative, you throw it out. Soon as I try to plug in x equals 0 here for this tangent, it would make 3 times 0 is 0. So I throw away this answer because I can't have a 0 tangent. So the only good answer here is x equals 4. And then the last formula you need to memorize for the segments is when you have two secants. So for example, number 5. So on number 5, what we're going to do here is we need to figure out the length of the whole thing. So for this secant segment, we need to add x plus 2 plus 2x minus 8. And I get 3x minus 6. Then I need to find the length of this whole secant segment. And I need to add all this. And I get 3x minus 4. So what we're going to be doing is whole times this external, and this whole times this external. So let me go ahead and write that out. So the pink one is going to be 3x minus 6 times the external piece, which is x plus 2. Set that equal to the other side, the blue, which was the whole times the external piece. I need to FOIL these and then combine like terms. So the pink becomes 3x squared plus 6x minus 6x minus 12. This will cancel. So now I'm just left with this. Then the blue foils into 3x squared plus 3x minus 4x minus 4. When I combine these, I end up with negative 1x minus 4. Now I need to work on getting my like terms together. So as soon as I try to put the x squareds together, notice it cancels from both sides. Then I'm left with negative 12 equals negative 1x minus 4. Add the 4. This one you didn't have to factor because your x squareds canceled. Sometimes that happens. And you end up with only one answer, x equals 8. So again, you have this scenario where you have a tangent and a secant, two secants, or where you have the intersecting chords. So again, there were other problems I did not complete, but again, they're using the same formula. All right, then the next one, this is a word problem. This could be something you might see. So notice here the 15, this is a tangent, and then they want you to find the length of the diameter. And the diameter is right here, and I'm going to call that x, which really is turning this into a secant segment. The 8 is the external, and then the whole secant is going to be x plus 8. So I'm going to be doing whole times external is equal to tangent squared. So my whole is x plus 8. My external was 8. And then my tangent is 15. So I need to distribute. I get 8x plus 64 equals 15 times 15 is 225. I need to solve for x, so I'm going to subtract 64. And I get 8x equals 161. I need to divide by 8. So now this is where if you make a careless division error and you don't understand how to divide to get a decimal and then round it, you're going to get points taken off. If you have all this work beautiful and you get to this and it's a calculation error, you'll lose minimal points. But what I want you to do now is round to the tens place. So you have to divide this. So I'm going to add a decimal. 8 will go into 16 twice. Bring down the 1. 8 will not go into 1, so 0. And now bring down the next 0. It goes in here once. Subtract, bring down another 0, because I need a hundreds place, so I can round it. So the 2 tells the 1 to stay the same, so this answer would be 20.1, and these were inches. So again, be able to solve a word problem, and again, be able to divide it and make it rounded into the tens place. And then the last section, 10.7, 2 formulas you're memorizing, or actually 3. You need to memorize that when the center is at 0, 0, all you need to do is fill in the length of the radius. The other one is when the center is at HK, and it'll just be an order pair that you're doing x minus h squared plus y minus k squared equals the radius squared. If you're looking for a radius, it's this same formula right here. It's just under a square root. So those are the 3 formulas from 10.7. We just did a bunch of these in the warm-up. So let me just do a couple from each section just to show you what you're going to do. So if you're given a picture of a graph, be able to pull out the center and also figure out the length of the radius. Now, remember, just like in big ideas, to pay attention to how much each box is worth. Now, these are all just 1, but remember, in big ideas, there was some that were like 3 for every box. So just pay attention to the scale. So what I'm going to do is I'm going to try to like eyeball and figure out where the center is, and it's right here. And the way that I'm going to confirm that I did pick the correct center point is I can figure out the length of the radius. I need to be able to draw in a radius to the right that has the same length. This has 2. If I draw it up, it's 2. To the left, it's 2. So I did find the correct center point, and that's going to be the order pair 3, 2. This is my h and my k. Again, I found the radius length to be 2. Now that I found the h, the k, and the r, all I have to do is plug it in to this formula down here. So I'm going to fill it in. So it becomes x minus 3 squared plus y minus 2 squared equals 2 squared, which is 4. So again, be able to write an equation when you're given a picture like this. Or if they just give you the information like this, h and k, and this is the r. And again, plug it in. Does that make sense? And then also be able to find the length of the radius given the h and the k and given an order pair, which is x and y. So for example, number 6, I need to find my radius length. So I'm going to plug in my numbers. So it's going to be -1 minus 4 squared plus -1 minus -1 squared, all under the radical. And let's simplify. So this becomes -5 squared. This becomes -1 plus 1, which just becomes 0. And then all under the radical. So 25 plus 0, square root of 25, and my radius length is 5. Now, be careful, again, when you're doing this, take the center point, not the other order pair. So we want the center, because remember the center is H and K. So let's plug it in. So my final statement here is going to be, your equation is x minus 4 squared plus y minus -1 equals the radius squared. Now again, I'm going to simplify this one and make it y plus 1. And I'm done. So again, be able to take a point in the center, find the length of the radius, and then plug it all back in. Also be able to take an equation and be able to graph it. So be able to pull out the center point, also be able to find the radius, and then graph it. Everybody good?